Alright, welcome back to Year 11 Math Methods, remote style. So, today, as we're starting chapter 5, I will cover 5a with set notation, followed by a relations domain and range for 5b. So, with 5a, it's really a quick review about the notation as we covered this notation in Venn diagram, in probability, and how to use sets. Um, so those ones are you should be pretty familiar with those. Probably the backslash is something to be mindful as well. It's a difference of sets. So the backslash b means the values in the set b will be excluded. So something to keep in mind. Um, all right, hold on. I just try. Yep. No. Okay. I guess I have to click somewhere here. Yep. All right. So with those examples, it relates again to uh, probability. So the notation with that intersection and the union with the solution. Have a look through the work example, and the same with the exclusion one. All right. Moving on with the notation. So just remember the notation with those capital letters for the set of specific numbers. So natural numbers will be the whole numbers, integers, positive and negative whole numbers, rational numbers for any number that can be expressed in fractional form, as an example a half or a third. Real numbers is anything else, especially thirds or constant or special numbers like pi. Interval notation, so be familiar with the inequality symbol. Also the shape of the bracket, as it is a round bracket, mean you exclude the boundary. If it's a square bracket, you will be included, so it will be an equal as well. Anything to do with infinity on the right hand side with the positive and the negative will be a round bracket. Let's look at some examples. Here you will have a different type of intervals, and you will have to annotate on the number line. The endpoint when they are included will be a full dot or a closed circle, and it will be an open circle if it will be excluded. If you have an exclusion like an infinity on the left hand side, you would just use an arrow notation. All right, with 5b, it's about relations and domain and range definition. So before we explain what the relation is, think about coordinates. So when you have a pair of two values, the first number will be the x coordinate, the second number will be the y coordinate. Together they will form a pair of numbers that will be annotated as a point on your Cartesian plane. When you have a set of ordered pairs, so usually you would order the first coordinate. They will form together, so those 4 points will form a relation. So that's the first relation. You use a capital letter to annotate it. The same idea as a set from 5a. The second one will be another example. Now when you look at the for example the first set, if I look at the x values, so they will be 1 1 3 5, that will relate to what we call the domain. So that's the set of all the first coordinates, and respectively with the range, that will be the 1 2 3 4 that correspond to the second coordinates. Let's look at some graphing. So the first one, in the same expression, you will have a set of points. So when you have a relation that is made up of a set of points, you will just place the points on your Cartesian plane. You will scan your x-axis and list all the possible values in order for the domain, And for the range, you will do the same. You have two values, so you have -1 and +1. With B, C, and D, so the way you could express the relation would you would have a relation or an equation in terms of x and y. From chapter 4, you should remember that this is the equation of a circle which is centered at the origin, and the radius will be 1. The next two ones will be the relation will be specifically a function. So y will be the subject, and the two of them are a linear function, so there will be a straight line, except it's not an extended straight line, as here you will restrict the x values to a from subdomain, and here it will be a shorter interval. So graphically you can see here x is greater than or equal to 0, so you go from the right hand side on the from the x-axis, so you extend it from 0 all the way to positive infinity. And for the this one, the example D, x will be between -1 to 2, so you start from -1 with a closed circle all the way to x equals 2 with a closed circle. So here you will have a segment, here you have half a line. Okay, and from all those graphs, what you do is you scan your curve. So here your curve goes from -1 to 1. Here you will write your range from x is from -1 to 1, or you could use this notation as well. This notation is more compact and quicker to write. For this line, you will go from -1 to 2 with square brackets. Here you have a quadratic. So in order to help you out with a sketch, first you would complete the square. You sketch the graph by placing your turning point. You probably will have also your intercepts, so y-intercept and x-intercepts if they all exist, and from that you should be able to state the range. The domain for any quadratics is going to be R, or all real numbers. So that's what it would look like. So you will have your completing the square. So here, do remember, when you complete the square, you take this amount, you half it, and you square it, and you cancel it out. So that's add a null value, which is your 4 minus 4. You end up with your turning point form. You read out the x coordinates and the y coordinate of your turning point of or your vertex. It's in a U-shaped form. There's no x-intercepts. The y-intercept is you substitute x equals 0 and you read y equals 5, and which you don't really need. But to state the range, because the vertex has a minimum, the smallest value of 1, you can list the range being from 1 included to positive infinity. And that's pretty much with it. But the last bit of 5b, similarly you have this example, but I just want to skip to that one, is as a definition, the domain you will have, which are the x values. The maximal or implied domain is the largest domain for which the rule of the relation has meaning. So when you have that example, you have an equation of a relation of a circle, which you have here. You annotate your points. Your left point is from -2, the right value is 4. The implied domain is -2 to 4. Next one, when you have a half circle, on the left you have -3, on the right you have +3. So your implied domain is square bracket, so it's from -3 included up to +3 included. All right. Before we finish, as I shift a little bit the order, have a go also at this example. So it is a parabola. It's already in turning point form. You have a a vertex of 0, 2, which is your lowest value. Just note that because x is going from -2 to 1, which is your domain, you substitute those coordinates into the into the function to get the y coordinates, and from here you can read the range. So the range is, even if you have a point over here of a y value of 3, your lowest point is y equals 2 and your highest point is y equals 6, so the range is from 2 to 6. And that's it for this first remote session, and I'll see you for the next on the next video.